Okay, this particular problem is a really good example of why you want to always practice reading very slow and careful. They did a couple of things here that I slipped into the error of trying to go too fast, and I was stumped for a little bit. So for example, it says the graph of the continuous. Now we don't need that clue always, but sometimes. So graph of the continuous function g, the derivative of the function f. So g is the, so this is where you have to read and process what it's saying. G is the derivative of f. So that means this is the graph of f prime. And the first time I was working on this, I kind of missed that because I just read way too fast. Function g is piecewise linear from -5 to 3. So here's x equal -5 to x equal 3. So piecewise linear. So this is linear, 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 linear. Got it. Okay, piecewise linear. And g of x, so this graph of g follows this formula here. So you want to read and understand what you're reading. Don't go fast. Yes, we're good to there. That's from 3 to 6. Okay, so that all makes sense. F of 1, again, this is the graph of f prime, but f of 1 is equal to 3. What is the value of f of -5? So it's this situation where I have f prime as a graph, and I want to find a value over here of f prime. I'm trying to find f of -5. So to get from here to here, thinking fundamental theorem. So here's the fundamental theorem. Someone yesterday asked a really good question in the Q&A. They said when they go to use the fundamental theorem, they struggle a little bit to remember. Write down the integral. What is A and what is B? Well, the two limits are going to be values where one value where you know f, right here, and the other value where you don't know f. So I'm going to integrate from -5 to 1. I'm going to integrate f prime. That must equal f of 1 subtract f of -5. Trying to find f of -5, so I rearrange. Oh, yep, that's right. So f of -5 is going to equal f of 1, subtract this integral, okay, let's keep going. F of 1 has a value of 3. This integral I'm going to find by paying attention to area. So start at -5. These values of f prime are all negative. This is 3 by 3, so that's 9. Okay, the minus was because of how I rearranged this minus was because of how I rearranged the fundamental theorem. The integral itself starts out negative because these values of f prime are negative. So I get 9. This is 3. This triangle here is 3 times 1 divided by 2. 3 over 2. It's also negative. No area here. That value of f prime is 0, so integrating 0 would just give a result of 0. This area is 2 by 1. This pen is annoying. 2 by 1 divided by 2, which is just 1. That counts positively. So that got us all the way to 1. So that's the integral. So I have found the value of f of negative 5. I can quit. There's no need to simplify. I might double check it there. That was a bit of work. So 3 makes sense. The minus was because of the fundamental theorem. This negative was due to this area here. This negative is due to this area here. Positive 1 is due to this area. Double check the scoring guide. And we're good. 2 points. They gave 1 point for seeing this, that you were correctly using the integral of f prime, then a second point for getting the correct result for f of negative 5.